Good night, everybody. Okay, we are live. I'm laughing because I'm eating this. Hope you have one near close to you so you can also. Happy New Year. Uh, Um, so the last episode, um, yeah, on this Geometric Cup was on December 18th from last year, and I said that I will be reading the book in front of you, but I decided not to do it because it is a lot of burden for me. But I didn't want to put the laptop somewhere like in the past I did and read the book and be silent. So I just read the book. And the geometry, the part of circles a little bit, and then some trigonometry. I didn't do the exercises because I justify myself saying, this is for Geometrikap. If I want to study mathematics, then I will do the exercises. Uh, right, and that's it. So let's get started. I'm not sure if we are ready to tackle the problem that we have in hand. Uh, uh, mm, mm, yeah, maybe an alarm. Wait, okay. So at 8:17 we finish, right? Just 1 hour. I said 2 hours, but it's too much. It's not too much. Actually, it's a unit that's supposed to achieve something meaningful, but I don't have. Just for today, maybe tomorrow 2 hours, but today not. No. So let's. Mm, mhm. Okay, what are we doing here? On my website, swear, apply private. Yes, I would like to take the Elixir version, even if this application is not an Elixir application, but it's running as as an Elixir application. They have achieved um, version 19, and I have a mess in this Debian. I would like to see if I can upgrade in a straightforward fashion, or it will be, or if it will be a major, major burden for ourselves, for us, okay, for us, get our English playground, geometry, projective, and the index. Oh my God, I don't know what to, okay, open with Edge. Look where we are. And then we open Debian, and let's change to my website. Oh my God. website. Sorry. Mm, but that's it. Let's see if I still remember how to open Visual Studio Code. If I maybe if I have some sort of assistant or manager about my online presence, that person will say that. Don't say that. You will look like this. I want to show you the real. We haven't opened code in quite some time. No, so that's what I said. Code, and well, let's see if I remember. That. If you're trying to send an image, well, you need like, hello, when you're doing this way, most people will remember. And Geometrikap. Oh my God, this JavaScript. Hmm. Now we have a lot of images in here, or folder of images. Oh my God, look at this. Now we are open this. We are going to open this with a snipping tool, and I'm going to use this. We have this. Um, this is some radius with point Q, radius R 0. Then you have an angle. It's theta. Then you have P. We have a formula. If you haven't following this series, you will know that the kind of tortoise, tortoise. Mm-hmm. I know some words in English, or maybe this was those kind of words that you tend to guess. So we have tortoise, the tortoise, and it's accurate because we were ignoring. Look at this, we were ignoring. We can say we were ignoring, but I wanted to say we were ignorant. All right, tortoise. Mm. Bands like winding pass or something complex. devious and non-straightforward. Yeah, it has been a torturous for us because we were ignoring. We were ignoring mathematics, but we were ignorant also about mathematics. And look at this. And then, yeah, that's in order to introduce this thing, we didn't reach 4 hours of Mandarin. I suppose it's not good. I think 2 hours is should be a maximum for this series. Ideally, half an hour. Very effective. Concentrated half an hour without this chit chat. I could, no, I feel like really like that should be cosine of theta, and then we have this. And if you are interested, this is beautiful mathematics. If you want to know, uh, because I was saying to myself, what's the use of these things anyway? This cosine, they are like numbers like 0.6, 5, 3, 1, a lot of numbers. And I was saying, so yeah, now wow, there is a lot of numbers here. What can I do with these numbers anyway? It's not the case that mathematics are to be applied, uh, forcibly applied. I don't know. But it turns out that in this realm, for this topic, uh, this cosine can give you the coordinates of the point P. The cosine function. Imagine that. That's surprising. That this, that these numbers that seems like never-ending numbers are very useful. You have your point. Now, if you want to learn how to calculate this, learn your trigonometry, we are using the calculator instead. So we are just using cosine of theta and then some radius. Okay, I'm going to delete or erase this original mark. And now in the past, said that uh, this, just bear with me. This is a line of 90 degrees, a line, an angle. This is also a 90 degrees angle. And if you have some other angles, this will be like 45 degrees. Um, this should be like 45 degrees. Imagine is you can think that it is the case. And the functions that we have been learning are the same. I was thinking for our case, um, for our case, it seems like I'm not sure right now. It's yeah, we have 0, 0. This is the screen, the viewport. I'm sorry, I was thinking the other. I didn't remember the video. If you haven't seen the video, check the video. I was saying a lot of ignorant things or some sort of naive things, silly things. I was saying we need to, to start the rotation from here. Since the straight edge looks like this, most angles that we have been studying starts the journey from here. But I want to start from here. And it can be done. But at some point, because these are valid angles, at some point, you will have to adhere to some axis in order to do your studies. You will say, in our framework, we are going to study these angles in this framework, in this little frame that we have in front of us. We are all agreed that we are going to start to rotate from here, or here, or here, right? With that being said, what I wanted to say is that these angles can exist in every direction, if you will. But at some point, you have to adhere to some axis in order to communicate ideas with other fellows. Okay, so now it's time for us to go to uh, the real thing. We have some rectangle that is our screen. And they say that this is the zero coordinate. And increments over here on the positives. This is the positive x. And they say also that this is positive y. Okay. If you have a line that starts from here, this line, remember this. This is the positive x. This is the positive y. Now you're going to apply a rotation of 90 degrees. The thing will be like this. This line will end on this position. Well, nothing new, right? We have been doing that from the very beginning. What we need to do is to rotate some image, set H, ideally from the midpoint. So it can be like this, but that is too much of a burden. It's too complex. So we are rotating a line instead. From here, if we manage to do that, then we can extrapolate the ideas and rotate our image. We are going to forget about the strategy for the time being. Our first step is to draw a line and then rotate it, rotate that line 90 degrees. 20 minutes. We have this. Mm, If you leave your code for a month or weeks or a week, then you will find yourself doing this. What is this? What is base color? So don't take this wrongly. Do your programming 10 minutes a day and your project 10 minutes a day, and you will have it on the top of your head every day. All right? It's your project. It's your little pet. You're petting your project like Shadow of the Colossus. There is this button from which this Wander, the character, do some petting to the horse like this. So this is this is your project, your creation, and you are coming every day and doing something like, okay, okay. How are you doing? At least 10 minutes. If you care about your project. Maybe it's not necessary in your case. Maybe you can leave it like that. Again, I'm not doing this. I'm just saying these words in order to procrastinate. Uh, it's easy to talk. Mhm. Okay, no more this, no more of this. And let's forget about this for the time being. Uh, and then, we have feel reg. We are not. This, this reg is too much. We need a line. Rectangle. Let us see if we have some sort of code completing. On draw line. We don't. So we go to npm developer by Mozilla. And you have this AI overview. Is this like coding? I don't think so. I don't like it. Okay, so this is again this is too much. Imagine all of these to draw a line. If we do the line, we will need to compute two points. If you want to rotate a line, given the API of the canvas, we need the line needs this, which is and you know, it's expected. And then, in order to rotate from here, we need to calculate this point, and we need to calculate this point. But remember, in our coordinate system, x starts uh, x, the positive direction. X is this. So 90 degrees will be here. As unbelievable for you as you think. So we need to compute this point. We need to compute this point in order to do some line two from here to here. This is quite a thing. So I'm not sure if we can do the rectangle. Um, the rectangle only needs this point. If we do a 90 degrees from this point, it will be like this. You know this. This is this. But this start to become hard again. If we find this, with the rotation, we don't need this either. Mm, 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 don't worry. We will solve this problem. We're going to take forever. This is a good thing to be thinking instead of messing around with other entertainment. Okay. Mm, mm, mm. I don't know what to I don't know what path to follow. We have two paths. the rectangle and the line. Since computing needs to be cheap, mm, there's no real cost to compute these 2 points as long as we move fast. But we are not moving fast. We are just talking and eating this thing and thinking on the consequences of our actions. That's good in real life. But in computing and programming, just the theory says that you should break the thing, right, and fix it as soon as possible. And it's easy, maybe for some cultures, for some backgrounds. But I suppose there is this, how you say, this ingredient of the background of the programmer, I want to mention that topic, but I suppose there is fear also, because we are translating the real life to the digital world. In the most cases, the digital world can have serious consequences on the real life in here. So maybe that's why people are very cautious. All the people. Some people doesn't want to even click a button. Uh, so I don't know how people can overcome that. If we move fast in this framework, nothing will happen. But, but still, maybe we are trained by the means of our history as humans, from what you there, Pearl, is saying. I haven't read the book. I haven't read the book. He's mentioned something called counterfactuals. What if um, maybe we are trying to calculate these things, and we want to calculate what will happen in order to save energy, maybe in order to save effort. Since maybe we are lazy, maybe we don't want to screw the things, even when in this scenario there will be no um, tragic consequences. But computing can have tragic consequences, uh, and the digital world too. So people should be aware of but just hey, let's go fast. But maybe in this case, for ourselves, we're trying to study ourselves how to see into our brains, like 100 steps ahead, in order not to even move. If you are over calculating, you will be freezed or frozen. I don't know. It's hard for me to know all of this and don't apply. It's not hard, it's silly. It's nonsense. But I feel good about myself, honestly, since I'm not into anything. Mm, so yeah, what if I don't want to change my mind? I like this way of, like most people think, hey, what if I do this? What will happen? Will I hurt somebody? Uh, yeah, so I'm not declaring bold. I don't want to retrain my mind. I don't want for this new mindset to, or this alternate mindset to influence my actual mindset. Not the little, not in the small way. I like my mindset in the way it is. Uh, so I rather take things very carefully, even if it takes forever. But if you are getting paid for a job, then you will say, hey, I need to deliver. I think we should read this book. But why we should read this book? Why are we trying to maximize or to optimize? You don't have to travel this life with all these ideologies, not to fall victim of any ideology or any fanatism or any group. It's hard, you know. We are going with the line. If we fail, then we're going with the rectangle. So we are going right here to MDM instead of the AI information. The Vegas already. Okay, we know this. Mm, we pass lines. Mm, arcs. In the past, I didn't understand this, but now I know. I was thinking, oh, it's too many parameters for this. But now I know. It's a point, the radius of the circle, the angle that you're going to rotate, and if it will be negative or positive, and you will end with these things. This is an arc, all right? The geometry is like amazing. That book has changed uh, my journey to discovering these things. I don't like this freaking pass. This AI did it without the. Oh yeah, they use freaking pass. It's the same. Oh, the energy. Oh. Oh. Maybe the line is too much. We're going to draw this thing at 100, 100, and uh, yeah, 100, 100 with where is line? This should be an horizontal line. We have the horizontal line, and we know something about lines now. Now the middle, well, this is great because we can draw, we can calculate the 90 degrees for this point over here without doing the rotation of the viewport. In order to apply with the formulas are going to work with the numbers that we have in place here. We should be able to calculate a point over here, given this width, this radius, and this starting point, and draw the thing over here. We can rotate the viewport, and we can rotate the viewport 90 degrees and draw a line over the x-axis with. Now we have another two branches. Remember, we they have, we are going to explore lines, or we are going to explore rect. We forgot about the straight edge. We went this way. Now we have another two branches. We can rotate the viewport, or we can calculate. See, we are trying to. No, this is. You have a deadline. I just stop the wandering and exploration. It's never ending. We will find more because we like that. We are going with the rotation in order for you, in order for us, in order for everybody to see. And someone will say, "You then you will never finish this thing." Well, our purpose. Where is this thing? Now we can do this. Our purpose. We have objectives. Look at this. We want to draw a line with the same width over here. We are going to explore two ways, two methods, the viewport's rotation and the calculation of this point with the trigonometry. Let's go first with the, let's go first, let's go let's first go with the viewport rotation. In order for that to happen, we will need to translate. I don't think 1 hour will be quite suitable for all the things we want to do. We only have 10 minutes. We can finish this, and then tomorrow do it. We can finish the line, and tomorrow do the rectangle, and the day after tomorrow do the straight edge. In order to achieve this, we're going to translate. Oh my God. To 100 and 100, which is here, right? We are going to translate this coordinate over here. I don't know why I am explaining this to you. This is not a tutorial. But you know I am like that. Okay. Now we're going to rotate 90 degrees. Rotate accepts in degrees. Um, Now I know one thing about radians. Let's see what are we doing here? Rotate in radians. So we need radians from degree. What do we get? Yeah. Now that we have the rotation, we are going to reset. Now we're going to establish it too. Maybe this is not necessary. Maybe the context says. But I'm not doing. That's another branch in our exploration, but we are not going that way. There are things that are related. It is never ending. Then you will find yourself exploring areas that are way beyond that mathematics or trigonometry or your application, and you will be doing some I don't know some how how guitars are building are built. You can end everywhere. I continue the exploration. Okay, let's use antique white. This well, if we do 100 and 100, viewport 00 is here. The line will be like this, but it will be here. We need to do it on 00 to be here because we have translated the viewport here. We are going to verify our prediction. This line should be rotated, but um, like something here or here. Nothing happened. What about our predictions? Maybe errors. Okay, no errors. Yeah, to leave like this. Okay. Like 100, 100. Why is not here? Oh, it's here. Uh, you see. Let's use another code. Besides, I have this issue with the screen. So it's here. Um, I don't know why both lines are red. So you can see it's here. Okay. Now we are understanding from 0, 0. Remember that the viewport was translated to here. This is the 0, 0. This is the 0, 0. Um, Now why is this is the 0, 0. So it should be if it will look at this 0, 0. So it will be an horizontal line. It will be 0. You see? We are going to explain the numbers. Okay, this was a little bit confusing, but we are about to clarify. Uh, so the radians, this is the, okay, this is the 0, 0. Then we rotate the viewport 90 degrees. Since we want a line that is intersecting, if you will, with this existing line, we should start at 0, 0, the line. Here it is, 0, 0. And draw a line on the x-axis, which is here, 100 pixels. This is the x-axis since it is rotated. So the viewport looks like. So this is the x-axis and this is the y-axis. But what if we didn't want to move the translation point to translate origin over here? What we need to do is uh, do some tinkering with the numbers, and we don't want to go that. We don't want to go. We don't want to go that way. When we look, this is the 0, 0, x axis, and y axis. So we're saying that we should move 100 and 100. This is the point 100 and 100. This is the point 100, 100. And then we draw the line, this line. But we didn't want that effect. That drawing is what we say in the code. Um, I read in, well, I learned in a training programming course that if you are debugging, you need to see what it does the code says. Okay, what it does the code actually says instead of why the program is not doing what you want the program to do. That's hard. Uh, Instead, read the code and you will say, this is what I have instructed the machine to do. The machine will not do otherwise. And then you can do. That's a technique to have in mind. And this drawing is what we said. Translate over here, rotate, go to this point and draw a line. So you cannot be surprised and say, why my line is not here? Well, your code doesn't say that. The code does not say to draw a line over here. Then we move, we tinker at the code, but uh, that's not what we were intending to, because we don't want to be calculating this manually. We want to leverage the coordinate system and the trigonometric functions. So here it is. I don't know why these two are red. If we are doing this reset, maybe, and in here it says yellow. Maybe there is another property of lines. Oh, you know what? So imagine living in a world in which you are refrained to learn. Here we go again with Veritas world. One more time. Caleb will spend more 30 more minutes because he's going now crazy again. He's going to start again with this Verita world. I cannot believe it. Does not help. If you are living in Verita's world and you're being injected thoughts on real time, you're uh, you're you're being deprived from the opportunity to learn, from the opportunity to exercise your memory. Uh, um, the memory skill, the memory capacity. I don't know how to say that. Yeah, in Veritas world, they're taking away your humanity. They are trying to help you. They're not trying to help you. They are testing these devices at the beginning, and then they will sell you your memory. They will remove the memory from you, and then will sell uh, your own memory. They will sell uh, your own memories on a subscription basis. They're not, and it is disguised in some speeches of, we're going to help you. We're trying to help you. That's not true. Just, we are getting again internet interruptions. It only works only if the person already knows. There is no way in this very that remember this is some sort of disconnection from reality. These things does not exist. Uh, they cannot have some sort of how you say, guys, in the healthcare. Uh, they will not have someone in the healthcare to write code by injecting those. They will say, okay, just what is this? They will not have a software developer making how do you say this? Some sort of let's go with I don't know, surgeon. How do you say that? Some surgeon intervention. They will say use this tool. This is for a fake thing, and it's only for the people that likes a fake that don't have any intellectual honesty, uh, that lacks every principle. They don't have values, maybe. It's for people just maximizing for profit. It's the money for the sake of money. That's the market uh, for that thing. And I know why the thing is not clear in the color. It's right. This, but I'm not fixing it now because we're going back to reality, and I would like to stay ignorant, right? We are leaving Veritas world behind. Forget about Veritas world. Forget about Veritas world. We are going back to reality. We are going landing Earth again. And look at this. How many internet interruptions do we have? And why is the case? I don't know. So I was telling you that I'm not fixing the color with this begin path. I Since we have left Veritas world behind and we're back in reality, we don't need to fix the color because we are not experimenting with colors. We are trying to find points in a coordinate system. So it will remain like this. So the thing is not working, right? It's a failure. This is a failure. This color that I'm not fixing is sort of it's failing, right? And okay, I don't know. We have shown the rotation path just by wanting to rotate from here. We did have to. We have to move the thing over here. Translate the viewport over here. Ideally, it should be here, somewhere in here, and then draw a line. But as you have seen, just with this, we have to recalculate a lot of points, 2 points. A lot of recalculation happened. So I don't think that's cool. So let's try the trigonometric functions path and see how it goes. We are not going with this rotation here. It was too much of a number crunching. So we are getting rid of this. I think it's not working. It's a failure. It's for the people. You saw that the kind of market of that thing. Now we're going this way. Um, okay, we are getting rid of this. Poor people in Veritas. What a way to screw the entire human race. And people collaborating with this just for the sake of having 5 houses, some private jet. Screw the whole thing, the whole humanity from the very beginning. That's kind of a thing to consider. I mean, it's screw the in Benita's world. There will be people thinking. So we went from medieval times, and it took a lot of time to go to into Renaissance. A lot of thinking, just for some. I don't know how to even call those people to screw the whole history, even from the very beginning. Is from a scientific point of view, this is oh my god, this is like the worst thing ever happened in Veritas world, and people are collaborating with this for the sake of having a private jet, maybe a fancy automobile. I don't know, maybe I don't know. Oh my God, this is like there is no way I could be part. I can be part of that thing. There is no way. I would say, oh come, no, there's. I'm not describing the entire history of my species. Come on now, no way. We are getting rid of. Actually, we need this just in case. Translate and rotate. We have those things over here, so we deleting it and deleting. Oh my God. We're going to get rid of all of this. We're back here. Okay, time to trigonometry. Trigonometry enters the East scene. Uh, enter the trigonometry. Mm, let us try this. It's 100, 100, yeah, 300, 300x, 300y, another line to 500. So here it is outline. So we can draw more lines. You see, that's why while I was taking a look. Now let's do some calculations to draw a line with this width over here. We're going to calculate this point right here. Mm, we're going to calculate this point over here because we have this. Quite naive starting point because we want to have this point and this point. Let's see this thing in action because I have like a calculation. This is a rotation of 90 degrees. Apparently there should be a. Oh my god! Now I need this. Even if I. Apparently we need this point. We already have this. This is the radius. This 100. We have this, which is radius 0, and this should be this should be r times cosine of 90 degrees. Let's see if this is going to work. Most likely, we will find some point over here because the origin of the coordinates is here. Well, that will be a good start, good starting point. Uh, let's delete this. I was saying that we are going to find a point over here, somewhere over here. We will have some line over here because the origin is here. We will find this. Then if that's the case, then we translate the viewport over here to the recalculation again, and we will find this. But again, we will doing this, and it will be straightforward. So let's get started with um. Oh my God, with this thing. Let's see if JavaScript has should be. Okay. So we have sign. This is sin. I don't know why it's pronounced sign. If it has the E, then it's sign, but here is sin. And we have cosine. Oh, good circle. We should spend the entire day with this because I would like to know what this thing does. This is a user-defined function by these guys. But what are they trying to do here? I don't know. It seems like interesting. They are trying to get some circle, you know, do some drawings with this function. Well, they are complicating the thing because they are trying to. Oh, here's the thing. Here's the example. It's no longer complicated. It's me. Not same radians. Uh, thank God we have get radians. Okay, we have sine. Uh, uh, we'll see. Wait. put the thing inside this thing. Maybe there is a way to access this. I don't know. I'm not exploring that right now. Yes. Okay, we have the sign. The radius is 100. Let's let's see what happened here. Okay, so the thing ended here. So we need to move again to the starting point. I don't like this. You see, now we are starting from here. Well, I don't like that. Uh, this thing will take us even more days. Um, it's okay. Now we can put these things over here. These things, these coordinates, these components. This is y, 1 times, and so remember, we said that we will find this point, and if you look, there is one. This is 0, 0, and found that this thing. We need to move the translated thing over here, which I don't like it either. Why do you like it? Like, why are you doing this anyway? Go and play the guitar or do something else. Enjoy the life. Why are you suffering? I like this, honestly, but I'm gonna say this to you. Uh, yeah, I like this. I cannot say that I think God is screw with me because even when I am unemployed, I still like this, but it feels a little bit different. But the good thing is that I never did this for money, not even for programming, but because I like learning. and I like discovering. And this programming has a lot of experimentation and discovery. Well, at this point, there are some new elements in my thinking that have moved the original intention of learning for me. Uh, I said to myself that this is for to share with the people some sort of application that they can use to do some geometry in a convenient way for them, in the couch, on the hammock, on the bed, uh, with their cell phones. Most likely there is zillions of applications, but I want for this application to be there. But at the same time, I'm taking advantage of this application to learn about a lot of things and to experiment and to really try to enjoy uh, this thing. I'm not quitting this application. I'm not abandoned. I'm not going to abandon this application. At the end, maybe we will be using some code generated by the prompt engineer, prompting some LLM for to give us the code. Uh, but I will document the thing. I will say, hey, look, I built this thing. And you will see if in the end we use the LLM. Nothing wrong with that. Nothing wrong with that. Especially if you download the models and you train the thing with some data available. Even a good exercise for you, maybe. It's a great exercise. I'm not doing that. I'm using what already is there, but you can do that. Uh, you know, have fun with this. Spend your life with this. So we're going to translate to 100, and this should work. Oh my God. What is this always? Remember that we are not, how do you say, resetting the thing, resetting the viewport. That's why we have this thing. Beautiful. I don't know how to call this, but you can sell it on a t-shirt. And look what we have built with code and use it on your t-shirt. $20. Support the channel, you know. Maybe that will make it into a t-shirt. Let's find if we have some other uh, if we forget something in the future, some error in the programming, and if it looks cool, it will become a t-shirt. Errors doesn't have to be bad. You can have a t-shirt with that, or at least use it at the starting point and do more lines over here. Well, not like that. That's a word, letter, a character that is becoming nonsense these days. So maybe over here, some circle. Let's see if this is going to fix the thing. It will be. There are a lot of lines in here. Uh, the thing didn't work. And, and what I was saying? Oh yeah, this thing. You can comment this line. Try to explain yourself. Trying to explain yourself why this is the case. You can draw some lines. Look at this. When this thing ends, the other line starts. Look, look. So you can find an explanation and put it over here, and you design the t-shirt. Here's so I forgot to clean thing. This is the explanation, and someone will wear this thing with the explanation with text here. Now, I'm not sure if there is 100 pixels from here to here. It seems like more pixels. We find this point. Translate to 100. Okay, we're getting there. So, oh my God, it's the same. We should have got written. We should have, uh, uh, here we go. We will try tomorrow again. We are done for today. Trigonometry works and it's beautiful. We should have deleted the approach with the rotation so we can see the code comparing both approaches and what approach requires more number crunching because we ended also moving to zero zero if I remember. We will have to re-exercise this thing tomorrow. 2 hours. Mm, yeah, tomorrow we will be 2 hours. Tomorrow, uh, this is amazing. Most likely the guys from the past were envisioning these things and these computers without even they were seeing this in their minds. So imagination has been on decay, I suppose. I don't have stories supporting my saying, backing my sayings, but I suppose uh, we are losing our humanity. Okay, next steps tomorrow. Uh, Re-exercise the rotation approach and comment this and see which one requires more tinkering, more number crunching, and decide decide what we are going to use. We have seen that the trigonometry approach worked. We didn't have to rotate. I think we should be able to with this trigonometry and some other we should be able to find this point over here and this over here. And that is the main challenge, even with lines. I think we can do it. I think it's possible. Once find a way. Maybe we are going to exercise the thing with both approaches. Once we find this, then we will use the rectangle, then we will use the straight edge. And I suppose by the end of this month, I'm not sure. Sometimes I do have only, uh, you know, I will try to do this thing 2 hours a day. But I'm not stopping the exploration, the discovery, and the chit chat. It's helpful for me. It's a thing for me. And I hope somebody gets something out with something of these videos. And when the thing is ready, we are going to start a course on geometry. As I'm not sure if I'm going, we'll be able to portray the philosophy of Helfand and Tatiana Alexeyevskaya. Uh, but I will try the spirit that those guys uh, to not to obscure the topic, to be available for everybody. I'm not sure. It's quite too much. Those guys were very passionate about mathematics, and it's reflected in their writings. I'm not that well versed in mathematics. So you say we did it. We find this point with the help of trigonometry. Hooray for the trigonometry. But trigonometry is a non-living thing. Hooray for all the people that came in the past that struggled a lot, all the mathematicians, all the people that were, I don't know, into insane amount of nonsense in order to make this possible. People building computers, uh, people helping the other people, providing food. No, I don't know. Hooray for the people who believe in humanity and work for the progress of the human race instead of the being detrimental for our human race. Uh, but yeah, we are celebrating early. We need to do this. If we do this, we are going big time. And if we finish this application, I will be happy. That's for sure. That's for sure. I will say, oh my God. Even when there is a lot of infrastructure already here, like this web browser, a lot of code behind this web browser and the electronics and a lot of work. You're building on the top of a lot of human effort. So I feel very satisfied with this result. Look at this online. This makes me happy these days. Can you believe that online can make you happy? That's the power of geometry. I remember having a lot of happy time with the book of geometry. Some people get happy with some numbers depicting the amount of money they have in their bank account. So those are symbols, and they are very happy with those symbols. And some other people are happy with mathematics. Some other people with poetry. Some other people with music. I feel very accomplished today with this line. Can you imagine this? Thank you very much, and see you tomorrow with more nonsense, naiveness, ignorance, incoherence. Uh, yeah, have a good one. 9 o'clock. I cannot believe it.